Moving on to other stuff you have to know for this test. The first thing it says here is vertex to general. And it's got a lot of mathy looking stuff. But the main thing you have to know is if you want general form, generally you just multiply it out. Just have to multiply it out to get general form. That works for the first thing here on here. And the last thing also is going from factor to general form. Generally, just multiply it out. So these two can be knocked off if you know how to multiply. You're good. Okay, finding the zeros is something that we've been doing in a lot of ways, and there's this way that you can just look at it and go, oh, 6 and negative 2 are the roots. Bing, I'm done. That's called zero product property. That's great. Doesn't always work though, because not everything is factorable. So what I need you to know is the main two things are, if you want to find roots, which are also the zeros, which are also the x-intercepts, there's a couple ways you can find roots. I just mentioned them. What's one way? Zero product property, ZPP. That's where they're set up like this. And you find the roots just by, oh, what does it makes this 0? Negative 3. What makes that 0? 2. Okay, and what's the other way you find roots? Quadratic. The quadratic formula. This would be worth writing down. When you want the roots, you do those two things. This one is the one that confuses a lot of people. If I want the vertex, there is now something you can just do. You can grab any equation, do this to it, complete the square. You got it. And we'll practice one of those in a second here, but those are the two key things that you really have to focus on. Is if you want roots, you got to know those two ways: factoring it with using ZPP or quadratic formula, and then find vertex. You got to complete the square. And then the other stuff just kind of falls in place, like when you got negatives underneath the square root, that's going to happen in the quadratic formula time. Like when you're working with quadratic formula, that's when you'll get negatives under the roots. So, all right. Moving on to other important stuff. General form to factored form. Basically, I just want you to factor this equation right here to make sure you remember how to do the simple kind, and we'll move up from there. Give it a shot. I'll pause while you work on it. So that one's pretty simple because you know that they have to multiply to negative 12 and add to 4. So you're thinking, well, could it be 12 and 1? No, they're not going to add to 4, so that can't be 12 and 1. How about 6 and 2? Do they make a 4 somehow? Yeah, they do. So it's probably 6 and 2. And then you'd say, well, one of them has to be negative because the answer to when you multiply them comes out negative. So it's either negative 6 and positive 2 or positive 2 and negative 6. And you just try it and you see what happens. If I make this negative 6 and positive 2, and I multiply out the outside and the inside, I would get negative 4x. Do you remember what I told you to do? Yes, if you get the exact opposite of what you wanted, change the signs around. And now it's right. Raise your hand if you had that one right. Good. Next one. This is a little harder kind right here in the red box because it's just got a GCF. So just take that GCF out of everything and then factor it. Pause while you do that. Okay, so there's the beginning of it. And now I can take my 3 and I'll stretch out this other part, factor it to x, and it's got to be a plus and a plus. And then what makes 8? It adds to 6. 4 and 2. There we go. Raise your hand if you had that one right. Okay, good. And why would you be doing this? Because then you could see the roots. What are the roots real quick? Negative 2 and negative 4. And now you know your roots, which are a lot of times answers to word problems that we'll talk about at the end here. The last one to factor is the one I'm going to put in the green box. Would you please factor this one? It's the hardest kind because there's no GCF and it doesn't start with a 1. There won't be too many like that, but you can do it. Okay, so I'm going to start with 2x and an x. And then I got to, is this the deal where if they multiply to 5 and they add to 11? No. They multiply to 5 though, they don't add to 11 or negative 11. They multiply to 5, that means it's got to be 5 and 1. We really gave you an easy one here. It's 5 and 1. It's just a question of where that 5 and 1 go. And one of them, are they either both positive or are they both negative? They're both negative because it ends up with a positive at the end, so they must be both negative. And then it's just a matter of where that 5 should go. And then it's just try it in the one spot. If it doesn't work, move them. Okay. So the way they are, they would make -7. It's not what I want. Got to move it. So move the 5 over here. And now I check the outside makes -10, inside makes -1. That's -11. That's what I wanted. All right. This kind. There's a lot of stuff to know, but none of them are really hard. From general to factored form. That's just factoring like we just did, except what's the difference? Because they said find the zeros. They didn't say to factor it. But that's how you find the zeros, is by factoring it. So really it's asking you to factor it again. So what would this one factor to? X and X and 1 and 5. There we go. And now I know the roots. What are the roots? 1 and 5. All right. 1 and 5. Okay. And halfway between the x-intercepts, you'll find the axis of symmetry. So if these are the x-intercepts here, they're at 1 and 5, then what's halfway between 1 and 5? 3. 3 is exactly halfway. If you're not sure, you just add them together, divide by 2, average them. Okay. So then if I've got this line that runs right down, exactly down the middle of them, now I can figure out the vertex from that, because if I know that I've got a, let's see, it's at 1 and 5, here's 1, here's 5, this line's at x equals 3. Now the equation was x minus 1 and x plus 5. There are 2 ways you can get this answer, and I've told you one before. Do you remember this? How far is that from that? That's 2. And then if I want to go down here, I know I have to go down here somewhere to get that. And you go down how far? You square that. And so that goes down 4. So it's down to -4. But there's another way. Wouldn't you agree that I could write x equals 3 because of this, right? Now, can't I just stick that x equals 3 in there? Wherever I see an x, can't I put a 3? So if there's a 3 here and a 3 here, then haven't I got y equals all that stuff? Yeah, I've got my y. So let's actually do it. So what's 3 minus 1? That's 2. What's 3 plus 5? I did something wrong. It's -5. You're right. Sorry about that. These are at negative. So I better rewrite that out. So it's x minus or plus 1 and x plus 5, and that was y equals. And the thing that was right down the middle of those two are at -1 and -5 are the roots. So here's a -1, here's -5, dot, dot. It's at x equals -3. So here's my actual problem. Sorry about that. So I can stick that number in here and here and end up with -3 and -3. So I end up with, what's -3 plus 1? -2. What's -3 plus 5? +2. And so it's y equals that, so it's y equals -4. Do it either way you want, but the answer is either way, you go down 4 to get there. All right, whatever's comfy for you. Just want you to have options. Okay, completing the square. This is just difference of squares again, which is really easy. We already talked about this. X plus 3 and x minus 3 would give you that one. Remember that? Okay, so this next part, the complete the square. This complete the square, x squared plus 6x minus 2. I'm going to do this one for you to just remind you how that works. X squared plus 6x plus 2. Here's how I do it. Plus a box, minus a box, and then plus the 2. I like having 2 boxes. Because whatever I put in that box, I also put in that box. And it just keeps it really simple. So if I take this number, I take half of the 6 and then I square it. One way to remember that is call it Heffen square. Sounds like a little German boy. Come and get your pudding, Heffen square. All right, I'm going to pause. So I have made the vertex form by using the plus box, minus box thing. I want to see if you guys can handle that. The vertex would be -3, -7. I'll give you an extra practice problem on that. Pause while I do that. I'd like you to try that one, and I'll pause while you do it. So there it is. How many had it right? Excellent.